Standing above the rolling hills, Kamiak Butte tells the story of an ancient ocean, glacial floods, and widespread volcanism. It is the home to many species of animals and plants, shaped by its location and composition. Located in eastern Washington, approximately 10 miles north of the town of Pullman, Kamiak Butte stands out above the rolling wheat fields. But how did it get here? 1.5 to 1.4 billion years ago, the coast of the North American continent sat at the western border of Idaho. Sediment off the granitic Idaho batholith was deposited in present-day eastern Washington in an underwater basin. From this sediment, quartz was preserved because it is extremely stable and resists weathering and erosion. Through millions of years of burial and compaction, these quartz grains became slightly metamorphosed quartzite rock. Through uplift from subduction to the west, this rock is now the basement rock for the region, and is at the surface in very few places, such as Kamiak Butte. Quartzite is very rare at the surface in this region due to the large basaltic lava flows that covered 210,000 square kilometers of eastern Washington, Oregon, and western Idaho in about 1 kilometer of basalt starting 16.7 million years ago. This lava was different in composition and behavior than the andesitic lava being erupted in the Cascade Mountains from the Juan de Fuca Plate subduction because it was much lower in silica and therefore much less viscous than the explosive mountain-building Cascade lavas. The rapid cooling of the lava flows also formed columnar jointing in a unique feature to this rock and important for groundwater flow in the Palouse region. 2.6 million years ago, the Earth entered a cooling period, causing glaciers to form the Cordilleran ice sheet covering much of Canada and northern Washington. 11,700 years ago, the Earth began to warm again slowly, melting all of the ice and snow that had been built up. This formed Lake Missoula, which was dammed by a glacial lobe. Eventually, enough water collected that the ice blocking the lake began to float and burst through the ice dam. This caused large floods through much of Washington that channeled out box-shaped valleys called coulees. These coulees formed what is known as the scablands from thousands of these floods. The floods transported large amounts of fertile glacial till that was then blown back inland from where they were deposited and formed the Palouse's windblown hills. Looking at this geologic cross-section, we can see the different stages of the region's history. The pink unit is the Idaho batholith granite that was the ancient coastline, above which is the tan quartzite units that formed from granite sediment and were uplifted then eroded into mountains. The space between the mountains were filled with basalt. Then windblown loess soils deposited over the region. Kamiak Butte is very similar to Steptoe Butte in this picture, that it has very little loess soil and mainly quartzite, which is well drained alternatively to the nutrient and moisture-rich loess soil. This impacts the plants that grow there, as we will touch on later. Located about 46.7 degrees latitude on the Earth, Kamiak Butte receives an intermediate amount of sunlight, causing 4 distinct seasons. The movement of maritime polar, continental Arctic, and maritime tropical air masses affect the temperature and moisture available in the Palouse region. The climate in eastern Washington has changed with the uplift of the Cascade Range since prevailing westerlies blow maritime polar air masses onshore but have become blocked by the mountains over time. This is shown in the figure by a decrease of precipitation in the rock record. In order to get over the mountains, these air masses, heavy with moisture, rise in the atmosphere while temperature drops, causing water to condense and fall as precipitation on the windward side. This creates very different environmental conditions on each side of the Cascades. The rain shadow effect and air masses have influenced the environment, forming communities of plants and animals that live in an expansive area with similar climatic conditions across the region. Kamiak Butte lies in the shrub, steppe, and woodland biome characterized by many low-lying plants and sparse trees across the landscape. These plants are adapted to low precipitation due to the rain shadow and can withstand a very large range in temperature from the influence of the regional air masses. We can see the differences between Washington biomes in this chart. Comparing region F to C on the chart shows that the eastern Washington shrub, steppe, and woodland, on average, has much less precipitation and is slightly warmer than the western Pacific coastal evergreen forest. Steppe grasslands are found in the interior of North America, such as Kamiak Butte, and the interior of Europe and northern Asia. These precipitation and temperature patterns have affected the time in which trees are able to grow on Kamiak Butte. Trees protect themselves from water freezing and expanding in their veins, damaging cells, by stopping drawing up water below 40 degrees Fahrenheit. The green arrow indicates the growing season for trees on Kamiak Butte. This growing season should be similar across the biome, but vary between biomes. The shrub, steppe, and woodland biome is home to many low-lying plants and sparse trees across the landscape. The shrub in this biome's name includes species such as sagebrush, hop sage, greasewood, and bitterbrush. Alternatively, the steppe plants are perennial bunch grasses such as bluegrass. These plants play a crucial role shading the ground, providing habitat to organisms, and reducing evaporation from the less soil below. The invasion and settlement of steppe land, once home to Native Americans, such as the Nez Perce tribe and Palouse people, transitioned the use of the land to agriculture and rangeland. Small patches of Palouse prairie remain in a patchwork of agricultural fields that now dominate the landscape. To this day, over 60% of the land supporting the shrub, steppe, and woodland biome has been converted into agricultural and rangeland. Some of this prairie land remains on Kamiak Butte. Differences within the biome can be seen in places such as the north and south slopes of Kamiak Butte, referred to as aspects, in the amount of vegetation visible. The difference seen between the north and south aspects of the butte cannot be explained through climatological differences, such as precipitation or weather patterns, since the whole region experiences the same climate. However, the ability of each side to hold onto its water does explain this difference. In the geology section, the ability of quartzite to drain water was touched on, but this well-draining quality also impacts the amount of water that can be evaporated from the ground. The south aspect receives more direct sunlight than the north aspect, resulting in more water being evaporated. This impacts the amount of dissolved nitrogen that is able to reach trees through the groundwater. With less water and nitrogen, these trees cannot grow as tall as those on the north aspect. Ponderosa pines are more adept to those drier conditions, as both Douglas firs and western larch prefer moister soils, and are much more common on the north aspect. Moose are an occasional visitor to the Palouse and Kamiak Butte, bringing with them much excitement, but also potential danger, as they can be aggressive around people. Moose likely crossed from Eurasia to North America via the Bering Land Bridge 10,000 to 14,000 years before present day. Speciation of the North American moose occurred when different populations were cut off from each other by the Wisconsin glaciation. The Shirasi moose, also known as the Yellowstone moose, can be found in the mountainous forest regions of the inland Northwest. The Shirasi have the smallest body and antlers out of North American moose species, but adults still measure around 6 feet at the shoulder. They have a brown coat that is lighter in the summer and darker in the winter to better camouflage in forest with the seasons. The native people of the Palouse region would take advantage of seasonal migrating large mammals such as moose, but also caribou, deer, and bison for high nutrition. The arrival of Europeans who viewed moose and their habitat as a resource to be used drastically decreased the moose populations around Kamiak Butte. Home to over 330 bird, mammal, and vegetation species, Kamiak Butte is an integral part of the Palouse ecosystem. It has been shaped through millions of years of geologic forces and influenced by regional climate to be the diverse mountain ecosystem many love to hike and explore today.